All right, in this video, I'm going to show you how to implement a decision tree, and the data is going to be from Kaggle again. So go to Kaggle and just search for heart disease. And you can say heart disease UCI. And the very first data set that you get is the one that we are going to need. Here, you have a data set that has 14 columns, and basically those columns show different attributes of patients. So, for example, their age, whether they're male or female, their chest pain type, and so many other variables. And the target variable is whether or not they have heart disease. So we are going to use decision trees in order to train an algorithm that is going to predict or classify patients into two groups, the ones that have heart disease and the ones that do not have heart disease. So go ahead and just download this data set. So I'm going to do now. And in the same folder that you would like to create your Jupyter notebook, and then make sure that you also extract it. In the same folder, and then you'd be ready to start using it. Then I'm going to, again, use Anaconda. Select the Jupyter notebook and create this in the same folder that I have already downloaded my data. You see the heart.csv is here, so I'm going to create a new Python 3 notebook in the same folder. Just like before, the very first thing that I do is to just change the name of this file. So I just call it heart disease, I say using decision trees. So first thing first, again, just as before, I'm going to import pandas and numpy into my workbook here. So I'm just going to import pandas as PD and import numpy as NP, just like before. This is just a code that you can copy and paste and keep it somewhere. You just paste it here whenever you need to run a machine learning algorithm on Python. The next thing that I'm going to do is to read this data set. So I just use, say, pd.read_csv, and the name of the data set that I have is called is heart. So heart.csv, and I just put this into a data set, which I call it heart. And I can just print the heading of this data set so that we can be sure that everything is fine. Oh, I should first run this. And then, okay. It's CSV, sorry. Okay, and you can see that these are the variables. So the ID number of the observations, and then we have a set of features, which are these. And by the way, in Kaggle, you can read the description of each of these variables if you wish. And then the target variable is 0, 1, indicating whether the patient has heart disease or not. So the task that we have at hand here is to train a machine learning algorithm that can classify patients into heart disease or not, into two groups. And previously, we talked about the KNN algorithm. In this particular example, we're going to use decision trees to achieve this goal. It's also good practice to take a look at the data types that you have. So here, let's see. And all of the variables that we have, luckily, are integer and float. So there are no categorical variables here. The next step would be to create the training and testing data sets using the train test split function. So go ahead and import it from sklearn as well. So we say from sklearn dot model selection import train test split. Let's just run it and everything's fine here. And now we can go ahead and define your data set. So we're going to have X test and X train, X test, Y train, and Y tests data sets. Going to be equal to train test split. All right. And we have to define the data set, which is the source. Here, in this case, is going to be the heart. And remember, the very first part is to define the features data sets, right? So the X part. And the X part is the whole data set without the target variable, okay? So if we want to choose the first columns and we want to remove the very last column, we can say heart.drop target. And target is the name of the last column, right? This is what we actually want to predict. So we are going to remove it from the training, from the X portion of the training and test data sets, which basically it's going to only include the features and not the label. Okay, so just, this is redundant. I don't need this. Okay, so that is for the feature. How about for the target? Again, the source is going to be the heart data set, and it only is going to be one variable or one column, which is our target. So basically, from the heart data set, the column target is going to be assigned as the label, and all the other columns except the target column are going to be assigned as features. Now, let's also define the size or the proportion of the observations that are going to be retained for testing. Let's go with, say, 20%. So test size is 0.2. It means that 80% of the data set is going to be used for training and 20% is going to be withheld so that we can use it for testing purposes. And in order to ensure that we are going to get the same set of results every time that we run this, we are going to use the random statement so that it's going to be always the same. Now let's run it and see if it's fine, and then let's see what the error is here. Okay, target. Oh, I figured because I'm using drop here, I have to use a 0 or 1 indicating whether I want the drop to be from the index or the columns. And here, because target is a column, I have to put a 1 here, and I put a 1, then it runs. And this is a future warning, so it's all fine here now. No, and I intentionally leave the mistakes that I make in the video so that if you have made the same mistakes, you know how to go back and fix them. Just to make sure that this has worked correctly, let's take a look at the information of our file. So the original file had 303 observations and 14 columns. Now let's look at the X-train part and see how many files there are. 242. And if we look at the, say, X-test, you would see that 61 are left in the test data set, which is fine and shows that this has been worked properly. All right, now we are ready to start the actual modeling process. So we are going to import the decision tree classifier from sklearn. So we just type in again from let me make it a little bit larger here for you. From sklearn.tree, import decision tree classifier, and then we're going to call it tree so that it makes our life a little bit easier. We don't need to type in the whole thing, and don't forget to add the empty parentheses after it, otherwise it wouldn't work. And then we just say tree.fit, and okay, what are we going to use in order to fit or train our decision tree? Well, it's going to be the X train and Y train. That is going to be the data sets that we use for our training, right? Then let's just see if it's fine. Again, what's the problem? sklearn. All right, so now it has run. Now we can go ahead and basically score it the same way that we scored the KNN algorithm in the previous video. So we just can say tree.score, and we can score it on the training and the testing data set. So I just say tree.score X train and Y train, and I make it put the values in a new variable. I just call it train data score, and I create another data set very similar to this, but instead of training, I would have the testing. So I call it the test data score, which is going to be based on the performance of the algorithm on the test data. And then I can print the results, and something like this. So I can say print the score of the decision tree in training data is, and then add a plus sign, and then add, this is for the training, add the training variable here. Now, one thing that you have to pay attention, as we reviewed in the previous videos, is that this train data score is not a string type, whereas the print requires a string data type. So what you have to do is to just use the str function in order to convert this into a string data so that it would run without any errors for you. Then you can just copy it. Here, don't forget to close the parentheses for the print. And just change the training to test. So here, this would be it, and let's run this. Okay, another problem here, which is, again, because of the parenthesis is not closed, and you get it. So here, the score in the training data set is 1, and in the testing data set is 0.73. This is actually what you really care about, the precision of the algorithm, or the test score of the algorithm in the training, in the testing data set, which is 0.73. So one of the things that you can do in order to improve the performance of the decision tree is to increase the maximum depth, right? It is the number of classifiers that it will go through. And one of the things and that you can do it is through here. So let me just do it here, and I can add the option of max depth and say equal to 4. So remember previously, let me just copy and paste it here so that I will retain my previous results. So what I did here is that I created a new function, and I call it tree2, in where the maximum depth of the decision tree is set to be equal to 2. And let me just put this here for all of the data, all of the code in the functions. I'm just going to use tree2. So let's run this and see what happens. Here you see that the accuracy of the model in the training data is actually reduced. So it's from 1, it's now 89. And in the testing, it is the same. Now, how about if you go from 4 to, say, 6 and run it again and see what happens? You see that in the training, again, it goes from to 0.97, and in the testing, it's actually improved to 75. And if I go higher and make it to 8, you see that, let me see. Okay, so did you notice that the results changed? It is now 72, and if I run it again, probably going to change. See, it went to 77. It's because of the randomness that is involved here. And if I want to ensure that every time I get the same thing, I can go and add the random state here. So now it's always going to be the same. Only if I can correctly type it. Okay. And now it doesn't really matter how many times I run it. Every time it's going to give me the same 7540. You see 7540, and if I run it again, I get 7540. So actually, let me go ahead and also include this random state statement and option in the previous one as well. So that, okay. Now every time we run it, we should get the same thing. See? 75. So now, just to show how the max depth is going to change, let's say we put this here to equal to 2 and run it. When you put it equal to 2, you have 0.77 and 0.75. And when it's put to 8, you get 1 and 0.75. Now, one thing that I want to pay attention is if I remove this max depth option, you pay attention to how the score in the training data set changes, right? If I remove it, it's 1. And no matter how many different times I run, it's going to be always 1. And the reason for that is that the leaves are pure. You know, the tree that is trained on this without any restriction on the depth of it is basically going to memorize all the labels on the training data set, and therefore it's always correct, right? What is going to happen here is that my algorithm is basically going to be prone to overfitting problems. That is one problem. And the other problem is that if I don't limit the depth of it, it is going to be very difficult to describe this decision tree and explain it. That is why it is very important to restrict the depth depending on the context and the accuracy that you want to get. So here is, for example, 8, and you see that it really does not improve it. When I go from 8 to, say, 3, I lose a little bit of accuracy in the testing data set, but not that much, and my predictions remains fairly consistent in terms of its score.